Physicists often study the simplest physical systems in great depth. This is because these systems, like the simple pendulum, collisions on an air track, or a thin lens, or crop up frequently in the study of physics. Sometimes it is not the simple system itself, but an analog or an extension to it. For example, it turns out that any periodic motion can be expressed as the sum of simple harmonic motions, as seen in the simple pendulum. The sound of this trumpet can be deconstructed into sine waves of different amplitudes and frequencies, which can be modeled by the simple pendulum. The basic collisions on an air track can be used to model the collisions of subatomic particles, and a thin lens can be used to describe the way that light bends around a cluster of galaxies. This week, we will be studying oscillations, and the simple harmonic motion of a mass on a spring. Oscillations are a periodic, back-and-forth motion. A periodic motion is one that repeats itself after a regular interval of time. A back-and-forth motion is one where the system comes back to its original state, after a regular interval of time. Watch this mass on a spring. It bounces back and forth, moving up, and then moving down. It crosses the equilibrium point, and comes back up. The equilibrium point is the central value, and is the place where the system would come to rest, if it is damped. This motion is periodic because each cycle of the motion takes the same amount of time. You can see the same behavior in this pendulum. The pendulum moves back, across the equilibrium point, and forth, past the equilibrium point in the other direction. This exact motion is repeated in a regular interval of time, called the period. A particular type of oscillation is a vibration. This is usually taken to mean an oscillation with a very short period, like the vibration of a guitar string. The spring and the pendulum are two of the simplest examples of oscillatory systems, but the behavior seen in these systems can be seen in dynamic systems in virtually every area of science. For example, the alternating current of the mains power, business cycles in economics, predator-prey population cycles in ecology, geothermal geysers in geology, and the beating human heart. The fundamental oscillatory motion of all these systems is the same, so your investigations of a mass on a spring this week will equip you with an understanding that will be useful in many situations.